Welcome back. Today we are going to discuss about Shor's algorithm. So before going to the Shor's algorithm, I want to discuss some background information about RSA encryption that we'll be using in all the mobile phones or etc. in phone base etc. So for long times, computers have used a trick to keep information safe. That trick is known as RSA. So RSA is nothing but reversed Shamir Adleman. So these we call it as RSA. So what they have done is nothing but they have chosen two big numbers, two big prime numbers. Let us say 3 into 5. I'm making it very simple. So if you multiply it together, you will be getting one value that is nothing but 15. So these 15 they will be kept publicly, but this 3 into 5 it is very secret. So just imagine it is a small number we can easily figure out. But just imagine like it is a 100-digit number or 200-digit number or 1000-digit number. Can you? No, right? So these have been breaked by Shor's Peter algorithm. So in 1994, so Peter Shor in 1994 found this algorithm that is nothing but Shor's algorithm, a quantum computer, so could factor big numbers exponentially faster. That means so it takes millions of years for normal computers, but it could take only seconds or minutes on a quantum computer. So it was the first time anyone showed a real problem that quantum computers could solve much faster than classical ones. So how? Now the question comes how they could factor these big numbers using Shor's algorithm. So let us go through the example of n equal to 15. I have to small example n equal to 15 and we can factor out the prime factors 3 into 15. But how? Just think of it is 10-digit number or 20-digit number. So it cannot be easy, right? So how this Shor's algorithm works, I will explain step by step. So we'll be having n is equal to 15, right? So in our example, so we need to trigger out greatest common divisor GCD. So a will be our random number and 15 will be our the example that we have chosen. So we need to first find what is a. So we need to check. So for example, GCD of 8 and 12, that is nothing but which is the divisor of both 8 and 12, 4. GCD greatest common divisor for 10 and 15, 5. So if you take 7 and 5, 7 and 15, you will be ended up getting 1 because for 7 you will be having only 1 and 7, and for 15 you will be having 1 comma so 3 comma 5. But if you take common in both cases, 1 will be the common divisor for 7 and 15. So we'll pick a as 7 in our example for n equal to 15, which you have chosen. A is equal to 5, that is nothing but GCD of 7 comma 15. So 7 comma 15 is equal to 1, right? So if you check the factors, if you look here, so 15 we will be having 1 comma 3 comma 5. Common factor is only 1, whereas in for 7 1 comma 7, in that both cases common factor is only 1. So 7 is a good choice for factoring out the prime factors for n equal to 15. So how we are defining the function? This is how we define the function in Shor's algorithm. F of x is equal to 7 power x mod 15. What is that? 7 power x mod 15. So you know the mod, right? See, if it is 7 mod 5 in this particular case, the remainder will be the result. Okay, the remainder will be your result. If it is 10 mod 3, 1 will be the remainder, so that is the output you need to write. So I have chosen some x values 0 to 4. If I take 0, so 7 power 0, any power 0 is nothing but 1. So if it is 7 power 1, 7. So 7 divided by 15, GCD of 7 comma 15. So you will be end up getting 7. So again GCD, now you choose x as 2. So if you choose x as 2, you will be end up getting 49. Now GCD of 49 comma 15. So you will be getting 4. Now you choose again 3. Again if you choose 3, 7 power 3 is nothing but 343. So you will be getting 13. So if you check here 1, 7, 4, 13. If you choose 4, again you are getting the same remainder, right? So again the same remainder you are getting. That is nothing but, as if you have chosen x is equal to 0, when you check it, you will be getting again same remainder. If you go for 5, again you will be getting 7. If you go for 6, again you will be getting 4. If you go for 7, again you will be getting 1. So this is repetition. That is nothing but 1, 7, 4, 13. So this is the repetition. So these four numbers are known as, we denote it as R, that we call it as period. Okay. So if you look here, 1, 7, 4, 13, again 1, 7, 4, 13, again that period will be repeated. So that means at every 4 steps pattern again repeats. So we call that as period, and we denote that period as R. That is nothing but 4 in this particular case, because at every 4 steps the same things are repeating, so we call it as 4. So now we know R is equal to 4. So this is the formula of Shor's Peter algorithm. So how we need to factor out the factors of n, that is nothing but prime factors of n. So GCD of a power r by 2, a is equal to 7, that we have picked already. R you already know, 4. Okay, n you already know, 15, right? So you already know these values. Now just substitute. So a power r by 2 is nothing but 7 power 2, that is equal to 49. So you have two cases, plus or minus, right? So 7 square minus 1, that is nothing but 48. 7 square plus 1, that is nothing but 50. So now compute GCD. So 48 comma 15 of GCD of 50 comma 15 you need to find. So if you take divisors of 48, you will be getting all those terms. If you take divisors of 15, you will be getting all these terms. So in these, 1 is common and 3 is common, rest they are not common. So common divisors are 1 comma 3, but we need prime factors, so we choose 3 because this is the only thing that is left other than 1. So now you go for GCD 50 commas 15. So if you take 50, so if you look here, in this 450 these are the divisors, 415 these are the divisors. Again if you look here, 1 is common and other than 1, 5 is common, so we choose 5. So the ultimate result is this, right? So we need to figure out the prime factors. That is what we can achieve. This is how Shor's algorithm works. I think this topic is clear. If any doubts, let me know in the comment section. Thank you.